Okay, let's see what's going on here. So first of all, we have a production of a product. So this in this case is it's a electronic thermostat. So we don't care. It's just a product that they produce, and there are some cost. So monthly cost, and there are two processes to produce that production. We have just index 1 and index 2 that represents the first way and the second way. And these are two costs, different ways to produce that production, two different ways, two different costs. So we want to pick the best one. So C index 1, which means the cost of the first way is going to be 20x. X represents the production. Remember that. Plus $10,000. Second, it's 10x plus $30,000. So they're different. And we need to pick the best one. And the question says, if the projected monthly sales are 800 thermostats, which means they will do that number. They will produce 800 units. And the question says if the selling price is $40. So those are the information we need, right? Selling price is 40, and we know that they're going to produce that number. Which process should be managed? Should we choose, or should we pick in order to maximize the company's profit? So what we're going to do in here is we will run this cost analysis for both ways and see which one's better. So the first one, if you consider the first one, that's the cost. We need to find out the revenue function. Revenue function is just selling price times production, which is X, right? So we already know that selling revenue function is 40X because the selling price is 40. So 40X should be equal to, so this is what we're going to do. We put a 40X equal to this whole thing, C index 1. And we just continue to find out the X. X would be the production that gives us 0 profit. So that would be break-even point. And we're going to get that number. So that number means if you produce more than that, you gain profit. You know that, you remember, right? And we're going to do the same thing for the second way as well. And based on those two, we can conclude something. So there you go. Like I said, 40x equal to 20x plus 10,000. And if you do that math, if you just put this one to the other side, it just makes it minus. So 20x, 40 minus 20, 20x equal to 10,000. And then doing the math, it's going to be 500. So 500 units. If you produce more than 500 units, you gain profit. That's for option 1. Let's see for what happens for option 2. The right side is different for the second way. So this time we have 40 equal to 10 plus $30,000. It's a little bit different. And if you do the math, this solution going to be, solution going to be 1,000. Remember that. Projected units going to be 800. The question was that, right? The question was giving us that information. So we're not going to get that number, 1,000 units. So for that reason, we can't go for the second way because we're not going to just get into that number. The first number is good, 500. The first way is good because if you produce more than 500 with the first way, you gain money and we can make profit. We can have some profit if we pick the first one. Second one, you lose money because you just gain money only and only if you pass that 1,000 units for this one. So here's a second example, another one. Let's just read the question for just a minute, and then I explain. Okay, so I encourage you to pause this if you need so, but let me explain. The question says that a producer is selling shirts for $5 each. So that means selling price is $5. So if you check this one here, we have profit equal to revenue minus cost. So revenue is selling price times X. So that's why we put 5X in here. His fixed operation cost is $3,000. So you remember that. If you remember that, cost is variable cost, or let's say cost per production, cost per unit, plus fixed. So that would be this one in here. So this whole thing is the cost function, variable cost plus fixed cost. So that $3,000 falls in here. This is the $3,000 because it's fixed cost. And variable cost or cost per unit per shirt going to be $2. So that's why we have 2x, because that's the definition. If you don't remember that, please check the textbook for business math to remember that. Or you can just have a little research or just go back to the previous slides. We had those equations. So not very complex thing in here. We have very simple formulas. Revenue, selling price times X, cost, variable cost or cost per unit times X plus fixed cost. So let me explain a little bit about fixed. Let me explain fixed cost and variable cost. We have two types of cost. Fixed are the ones that we need to pay anyway, and they don't depend on production. So you have just those costs. It doesn't matter if you run your business or not, you're going to pay them like your rent. If you have something, if you just rent a place to produce something, you have to pay the rent anyway. It doesn't matter if you're working there or not. It doesn't matter if you're shut down, you have to pay that. So variable costs are different. So those are the ones that they depend on production. So that means something like material costs, something like a labor work. If you produce more, you need more labor, more people, you have to pay them more. So that depends on the production. If you just shut down your business, you're not going to have those kind of costs. But fixed are the ones that you need to pay anyway. So anyway, write down the equation of the profit in terms of numbers of shirts. And here you go. That's the solution. So you just put them all together. You have a minus in here outside the bracket. If you multiply that minus to every single one of those, it's going to be this. And if you add the like terms, if you remember in math, you have to add the like terms, are going to be 3x minus 3,000. So that's the formula. This is the formula we need for modeling. So please try to answer the other parts, find the profit. If we produce 5,500 shirts, you have the formula, you just need to put that 500 for X and solve it. Find the break-even point, and for break-even point, you need to put 0 for profit and find X. So just in here, if you put this whole thing equals 0 and solve it, that would be break-even point. And if you have the number for production, you can put it there and find out P, which is profit. So these are these two parts. So let me have a pause. So let's just have a little pause in here, read the whole question, the situation, and let's think about that, and then I'm going to explain. So if you need, pause what I'm going to explain in here. Let's imagine that a product with a profit function of this, P function of X is equals to 10 times X. is being produced. So we would like to maximize this weekly profit. So that means more production, more profit, right? But what if you have some restrictions, right? Is it realistic? Yeah, we have restrictions all the time. We can't just stop. This is the profit function, and based on that, if you produce more, you're gonna have more profit. So we can't go for any number we like, because this is not math. This is reality. This is all about reality. This represents the reality. We can't produce any number we like. We have some restrictions. We have, for example, a maximum possible number, right? And we have other restrictions as well. So in this case, if you check that, the question says, what if the operation hours are limited to 40 hours per week? Okay. And let's say every product requires 5 hours of production, 5 hours of operations to be produced, and we have only 40 hours per week. So that's the kind of restriction we have. So this means what? This means 5x. So yeah. So if you remember, x represents the number of production. So 5x means what? Means total number of hours that we operate. So hours of operations. 5x should be less than and equal to 40 hours, because that's the maximum possible hours that we can spend weekly. So that's one restriction that we have, and we have everything in math. So we have a formula that represents the restriction. And one more restriction: x cannot be negative, because we cannot produce something like -1. We can't produce negatives. So it doesn't mean anything if you just report a negative number for production. So here we just have a little, just a little heads up. We're gonna have this discussion later, but just for your information, we have two different types of modeling: deterministic and stochastic. So the first one, deterministic, are the ones that we know the numbers, we know the information, the input data, they are fixed. They're not going to change. Everything is known. We know that the selling price is going to be that, the variable cost is going to be that. We have some constant numbers. And if you have that kind of situation, that would be deterministic modeling. And the other one is being called stochastic or probabilistic. In the second models, numbers can be different, so they can change a little bit. Not just anything they want. They can be different. So, for example, we can have a selling price which is based on something else. So that's not a fixed number. For example, it could be varied based on supply-demand change, right? Or operation hours, they could be different depending on something else. So they could be different, like in between those two numbers. They can vary. They can just be between minimum and maximum value. So sometimes they're fixed, numbers are fixed. We call them deterministic. Sometimes numbers are different and they can change. We call them probabilistic modeling or stochastic. So this is another example of deterministic. I encourage you to read that and have a pause. Okay, let me explain again. So this ACE novelty is just a name, doesn't matter. This production has two products. type A and type B. Each one of those, they have different selling price and different situations. So type A, souvenir, will result in a profit of $1, and each type B will result in profit of 1.2. So the manufacturer of a type A requires 2 minutes. Like I said, two different scenarios. They have two types of products and two different restrictions and information. So type A requires 2 minutes on machine 1 and 1 minute on 1 minute on machine 2. So they have two machines, type 1 and 2, machine 1 and machine 2. So type A requires 2 minutes on machine 1 and extra 1 minute on machine 2. Type B, different situation, requires 1 minute on machine 1 and 3 minutes on machine 2. There are 3 hours available on machine 1, 5 hours on machine. So you know what's happening in here is that we have some restrictions. We have some restrictions, different types, different, like we have restrictions on prop. Sometimes we have like on hours, sometimes on some other kind of areas. But what we should do to solve this question first is to summarize all the things that we know. You know, we have all types of these numbers in here, and this is kind of like it's a crazy situation. But if you summarize everything that you know on the paper, right, you can deal with that. And it's going to be better and easier to understand and easier to solve. So the question is how many of each type we should produce or they should produce to maximize the profit. So there you go. The first step is to summarize the question, like I said. And the best way to summarize the question, one of good ways, and here in this situation, the best way is to make a table. Make a table and put all those information that you know on the table. So here, the columns are types of productions. These, right? Columns are type A. These are products, right? And over here, we have restrictions. So remember that. Products here, restrictions here. So we have machine 1, machine 2, and type A, type B. And we put all the things that we know from the question on the table. So remember that. Type A requires 2 minutes on machine 1 and 1 minute on machine 2. Type B requires 1 minute on machine 1 and 3 minutes on machine 2. Total time that we have for machine 1 is 180 minutes. Total time for machine B is 300. If you want to check, get back and check. So let me find that here. Yeah, it could be missing on this, so I can find that right now. Yep, it's right over here. So there are 3 hours available on machine 1. That means 180 minutes. So, and 5 hours on machine B. Oh, sorry, machine 2. So these are the other restrictions that we have, and we put those here. So that's 5 hours, and this is 2 hours. Oh, sorry, 3 hours. So 3 hours in here, 3 times 60, 180, and 5 hours in here, 5 times 60, 300. So these are everything that we know. If you remember that, the profit for 1 unit of type A is $1, 1.2 for unit for type B. So these are everything that we know, about the question, summarized version of the question, a table with everything that we know. That's the first and the most important part of the solution. And X is the So to deal with to formulate, right, to make the models, formulas, mathematic modeling, we need variables, x and y's. In this case, we have two types of products. So we have to use two different variables. So for that reason, we're gonna assign x for type A and y for type B. So y gonna be type B, x gonna be type A. Don't mix them up. So if you do that, we can make up these formulas. So x plus 1.2, it's going to be profit. Why? Because for every x we sell, we gain $1. For every y we sell, we're going to get $1.2. So if you put them all, if you add them all together, that's without p, total profit going to be x plus 1.2y. That's the first formula that we need. This is the profit formula, profit function. And we want to maximize this. Okay, we want to maximize this, but there are restrictions. This is the first restriction that we have. 2y plus 2x plus y should be less than or equal to 180. Get back to this table here. Remember that? It just takes 2 minutes. So every x takes 2 minutes. So 2x plus 1y should be this. 2x plus y less than or equal to 180. 1x plus 3y less than or equal to 30. 300. Again, x, y. 1x plus 3y should be less than this, or at least equal. 2x plus 1y should be less than this, or at least equal. So this is how we can formulate profit restrictions. It's going to be like that. And we have one more restriction. Like I said, we can't produce a negative number, so they have to be positive. Both of them, they have to be positive. So if you put everything that we know together, this is the whole mathematical models. This should be the whole question in kind of computer modeling. So we have everything that we need. We have mathematical modeling. We built everything in here. And now we just need to use a tool to find out the final solution. So we're almost done. But we're not going to solve that whole thing in here because this is the first class and we just want to make up these models, not to solve it yet. We just want to understand the problem. Remember that the understanding the problem is the most important part. So understand the problem and find out the models. And then later we work on those and see how we can find the solution, the best solution.